In 2010 past paper, question number 10, based on part B. Question number 10, part B, based on the nitric acid and ammonium sulfate fertilizer production. Can you see, Buddha, here? Have you go through the nitric pathway? Nitric having
Yeah.
pathway? No. Yeah.
Yes.
Yeah. To obtain nitric, have you remember? We need to have ammonia and oxygen, but
Yes.
starting material come from air,
Natural. Yeah.
natural air, natural air. Nice. In here, part B should uh, natural air, and here separation fractional distillation.
It means
We
oxygen.
Yeah, we take out nitrogen and we have byproduct oxygen.
Okay.
Okay, in this way, this is nitrogen, and also you can separate this ammonium sulfate into two, ammonia and sulfuric, right?
Mhm.
And one of this arrow belongs to ammonia, one of these arrow is belong to sulfuric. Okay, divide into two. Got it? No.
Yes.
Yeah. Yeah. In which direction ammonia having direction? Which direction? From which direction? Here we have nitrogen.
Yeah.
This path belongs to ammonia. Belongs to ammonia. And the other path for this arrow belongs to what? Sulfuric.
Exactly.
Can you see how many industries here? Sulfuric, ammonia, nitric. Sum of three industrial processes here. Okay. To produce ammonia, go upward. To produce ammonia, we need two kind of reactants. What are they?
And hydrogen. The
Hy-
nitrogen and hydrogen.
Nitrogen and hydrogen. So this F is belongs to production of ammonia production. Ammonia production. Okay. The conditions here, 250 or 200, 250 or 200 to 300 atm, 450 degrees of Celsius conditions, and metallic metal catalyst,
Yeah.
metal catalyst or and yeah, metal catalyst. We can use also metallic oxide Fe2O3 also. Yeah, right. That's it. After that, we know the production of ammonia. And can you see? I think yeah. I think missing arrow here. And this one belongs to sulfuric, no? Sulfuric
Yes.
production. Starting from sulfur O.
Burning of sulfur.
Yeah, this one sulfur O, no? Sulfur O. Burning in air, resulting sulfur
SO2. That's
SO2. Nice. SO2. Can you see the same triangle here?
yeah.
Yeah, yeah. But air having oxygen reacting with sulfur dioxide. What are the conditions here? 450 degrees of Celsius.
Vanadium
Vanadium pentoxide
pentoxide.
and
Uh, 180. Yes.
180 atmospheric pressure and resulting SO3.
Yes.
Adsorption in Z. Z means concentrated
Sulfuric.
sulfuric and resulting
Sulfuric.
oleum,
Uh,
oleum, oleum. This one oleum. After mixing concentrated sulfuric and sulfur dioxide, resulting oleum dilution with water, oleum dilution with water resulting sulfuric. Yeah. Now we have achieved two industries. Remain one. We can go into this direction. This one, you can see starting from air. This one ammonia. Ammonia takes out, and here we have oxygen. Oh yeah, right? Yeah, and ammonia reacting with oxygen, resulting product is nitrous monoxide, basic product. Okay. What are the catalysts? Platinum and rhodium. Platinum and rhodium catalyst.
800 to 900 Celsius degrees.
Celsius, in between 800 to 900 to 1000 Celsius. And yeah, ATM1 resulting NO. NO reacting with O2 gives NO2 to this circle. NO2 into water and oxygen is there also for nitrate, right? NO, O2 and water.
Yes,
HNO3. Now we have remaining one, electrolysis. Here,
should be oxygen. D.
Sorry?
Water. A should be.
A should be water. Yeah. Can we use sea water? Sea water. We can use sea water. Electrolysis. Electrolysis. Bioproducts. Sodium chloride, no?
Yes.
What? Chlorine and sodium hydroxide. Chlorine. Yeah. Seawater or sodium chloride electrolysis and resulting hydrogen and chlorine and sodium hydroxide also. Yeah. Pute, any troubles?
No, sir.
Okay. I will try to. Have you past papers? No. Have you industrial chemistry past papers? No.
No, sir.
No.